Hello, good afternoon everyone. We are the Group 5 and thank you so much for attending our presentation. Today, we will discuss the chemistry of the atmosphere together with the subtopics, the atmosphere's composition, evolution, and structure. Hola, I am Eileen Amistosa to give you the definition and the overview of the chemistry of the atmosphere. We have arrived at the first stage of the atmosphere. Have you ever wondered why the sky is blue? Or why the sunset and sunrise are orange or red? I am here to tell you that the primary cause of a blue sky and red or orange sunset and sunrise is simply the scattering by the gas molecules that made up our atmosphere. For a better understanding, please refer to the illustrations shown on your screens right now as I explain the reasons behind them. The light that looks white to our eyes is actually made up of different colors. Each color can be thought of as a light wave with a different wavelength. The wavelengths of different colors are shown in illustration 1. As you can see, the shorter waves are blue and the longer ones are red. Colors such as green, yellow, and orange lie in between the blue and red ends of the visible spectrum. Next, please focus on illustration 2. When they reach Earth's atmosphere, the light waves can interact with particles in the air, like dust, water droplets, and ice crystals. Dust particles or pollution affect or even enhance these colors. Because of the extremely small size of visible light waves, these light waves also interact with the tiny gas molecules that make up the air itself. As the light waves bounce in lots of different directions, we say they have been scattered. Particles that are small compared with the light wavelength scatters blue light more strongly than red light. Because of this, the tiny gas molecules that make up our Earth's atmosphere scatter the blue portion of sunlight in all directions, creating an effect that we see as a blue sky. Within the visible range of light, red light waves are scattered the least by atmospheric gas molecules. So at sunrise and sunset, when the sunlight travels a long path through the atmosphere to reach our eyes, as shown in illustration 3, the blue light has been mostly removed, leaving mostly red and yellow light. I am sharing this fact because it is one of the direct consequences of the existence of the atmosphere. In simpler definition, the atmosphere is a thin envelope of gas molecules surrounding the Earth, and it is held down by the Earth's gravitational pull. While oxygen is necessary for most life on Earth, the gas in the Earth's atmosphere is not just oxygen. It is composed of different gases such as nitrogen, argon, oxygen, etc. The atmosphere is about 500 kilometers thick and it has 5 layers. But don't worry because the composition and the structure of the atmosphere will be discussed later on. We all know that the ultraviolet radiation can be harmful to us in so many ways, and we also need warmth to live. So, the purpose of the atmosphere is to protect us from any radiation and rays that may enter, and trap the heat to keep the Earth warm enough for life. Certainly, the atmosphere is important because life wouldn't exist without it. The important sides of the atmosphere in relation to its purpose are: first, it contains the gases that we need in order to live. Second, it maintains the Earth's temperature by absorbing the sun's energy as it arrives. Then, it spreads the warmth across the planet and for preventing the night side of the planet from becoming too cold. And third, it protects us from harmful ultraviolet radiation. How does it work? Again, please refer to illustration 4 for a better understanding. Some solar radiation and some infrared radiation are reflected by the atmosphere and pass through it respectively. Also, infrared radiation is emitted by the Earth's surface, but most radiation is absorbed by the Earth's surface and warms it. A few weeks ago, we talked about heat transfer, and in the atmosphere, there's also a heat transfer. Heat moves in the atmosphere the same way it moves through the solid Earth. It radiates from the ground into the lower atmosphere. Heat can be transferred by three processes, namely conduction, convection, and radiation. In the atmosphere, conduction is more effective at lower altitudes where air density is higher. It transfers heat laterally from a warmer to a cooler spot where the molecules are moving less. The heat moves from areas of more heat to areas of less heat by direct contact. While in the convection part, heat is carried upward from the Earth in convection currents. Heat that radiates from the ground initiates convection cells in the atmosphere. In radiation, the energy is transferred by waves. Energy can travel as electromagnetic waves through air or empty space. The sun's energy travels through space by radiation. After sunlight heats the planet's surface, some heat radiates back into the atmosphere. Radiation is the least important mode of heat transport in the Earth, but it controls the temperatures at the Earth's surface.
Hola, I am Joshua A. Espinosa. So for today, I'm going to share with you what are the composition of the atmosphere. The composition of the atmosphere. Do you know what gases make up Earth's atmosphere? So let's learn together on what are the composition of gases exist in our atmosphere. So our atmosphere is like a blanket, just like a warm blanket that protects us from the cold night air. Our atmosphere surrounds the Earth and protects us from the harmful effect of the sun. So the first gas that is considered the most abundant gases in the atmosphere is nitrogen. Nitrogen has 78%. So consumers need nitrogen but can't get it from the air we breathe, right? So instead it comes from the food we eat. So in here we have nitrogen fixation. Are you familiar with nitrogen fixation? So nitrogen fixation, plants cannot take nitrogen directly from the air. Nitrogen is removed from the atmosphere through the process of nitrogen fixation. So most nitrogen is done by bacteria in the soil. The second gas that considered the most abundant is the commonly oxygen. So oxygen is having 21%. So humans and animals take in oxygen gas in breathing. Plants produce oxygen during photosynthesis and balance the oxygen content in the air. Next, we have other gases make up approximately 1% of the atmosphere. So we have argon 0.9%, carbon dioxide 0.04%, and trace amounts of neon, helium, methane, krypton, and hydrogen, as well as water vapor. They're having only 1%. So carbon dioxide, although carbon dioxide levels are relatively low, but it plays a large role in our atmosphere. Plants use carbon dioxide to make food and release oxygen. Carbon dioxide is a greenhouse gas, which means it traps heat from the sun and slowly warms our atmosphere. So we have human impact on CO2, or the carbon dioxide in the atmosphere. So human impact the environment by burning fossil fuels, having driving cars, and deforestation. This excess of carbon dioxide leading to problems such as global warming. Next, in history, John Dalton recognized that the atmosphere was in fact composed of several chemically distinct gases which he was able to separate and determine the relative amounts within the lower atmosphere. He was easily able to discern the major components of the atmosphere, like nitrogen, oxygen, and a small amount of something incombustible, later shown to be argon. So the development of the spectrometer in the 1920s allowed scientists to find gases that existed in much smaller concentration in the atmosphere, such as ozone and carbon dioxide. So the concentration of these gases, while small, varied widely from place to place. In fact, atmospheric gases are often divided up into the major, constant components and the highly variable components, as shown in Table 1 and Table 2. First, let's show first the Table 1. So we have nitrogen, or the N2. Nitrogen has 78.08%. Oxygen has 20.95%. Argon has 0.93%. Neon, helium, krypton has 0.1%. So Table 1 constant components, proportions remain the same over time and location. So for Table 2, we have carbon dioxide has 0.038%, water vapor has 0.4%, and methane, sulfur dioxide, ozone, and nitrogen oxides is called trace, or having trace. They're called trace because they exist in small amounts of gases. So the percentage remains at exactly 0.1%. So of the atmosphere consists of the trace constituents. So that's why they're called trace. So although both nitrogen and oxygen are essential to human life on the planet, they have a little effect on weather and other atmospheric processes. The variable components, which make up far less than 1% of the atmosphere, have a much greater influence on both short-term weather and long-term climate. So for example, variation in water vapor in the atmosphere are familiar to us as relative humidity. So water vapor, CO2, CH4, and N2O, and SO2 all have an important property. They absorb heat emitted by Earth and thus warm the atmosphere, creating what we call the greenhouse effect. So without these so-called greenhouse gases, the Earth's surface would be about 30 degrees Celsius cooler, too cold for life to exist as we know it. So though the greenhouse effect is sometimes portrayed as a bad thing, trace amount of gases like CO2 warm our planet's atmosphere enough to sustain life. So global warming, on the other hand, is a separate process that can be caused by increased amounts of greenhouse gases in the atmosphere. So in addition to gases, the atmosphere also contains particulate matter such as dust, volcanic ash, rain, and snow. So these are of course highly variable and generally less persistent than gas concentrations. But they can sometimes remain in the atmosphere for relatively long periods of time. So volcanic ash from 1991 eruption for Mount Pinatubo in the Philippines, for example, darkened skies around the globe for over a year. So do you know what is the important cycle to maintain a stable climate in our Earth? It is called the carbon cycle. So carbon cycle is describe how carbon transfer between different reservoirs located on Earth. So this cycle is important for maintaining a sustainable climate and carbon balance on Earth. In addition, carbon is released back into the atmosphere when organisms die, volcanoes erupt, fire blaze, fossil fuels are burned, and through a variety of other mechanisms.
Hola, I am Princess Erai to explain the evolution of the atmosphere. We have arrived at the third stage of the atmosphere, wherein I'm going to explain with you the evolution of the atmosphere. The development of the Earth's atmosphere over geologic time is referred to as atmospheric evolution. The process by which the current atmosphere evolved from a former condition is complicated, yet indirect evidence about the evolution of the Earth's atmosphere is plentiful. Past changes in the air composition due to the chemical reaction with the Earth's crust, particularly biochemical activities linked with life, are recorded in ancient sediments and rocks.
How did the evolution evolve throughout the years? For describing the process of its evolution, we have these three stages that we'll be tackling today. These three eras are somewhat a story of how the atmosphere is formed. The evolution of the atmosphere process took over millions of years, and it correlates to the Earth's origin and evolution. In describing the atmosphere evolution, there are these stages of the process. The three stages of evolution: primitive, or the first atmosphere; reducing, or the second atmosphere; oxidizing, or the present day atmosphere. Then, let's cultivate each era. Primitive, or the first atmosphere. The solar nebula was responsible for the formation of the Earth, which occurred approximately 5 billion years ago. When the Earth was made, it almost didn't have an atmosphere. The atmosphere was formed through the spewed gas from the volcanic eruptions. Hydrogen, helium, water vapor, nitrogen, carbon dioxide, and carbon monoxide are the gases dominated the atmosphere at that time. The main gases that the atmosphere has was hydrogen and helium, because these gases are formed by the sun and they move so fast and then released to the space. The temperature was too high because the main gases and the Earth's gravity was weak due to the lack of the differentiated core. These gases were released into the space. Reducing, or the second atmosphere. This second atmosphere was formed 3.5 to 2 billion years ago. As I said a while ago, the first atmosphere was formed 5 billion years ago, while the second atmosphere was formed 3.5 to 2 billion years ago. Condensed water vapor formed the hydrosphere around 4 billion years ago, resulting in massive seas. During the first atmosphere, the only water present is water vapor. But during the second atmosphere, the water vapor condenses that it causes it to liquefy. The first life that occurs is the water bodies. The Earth cooled down at this time, and the layers were differentiated into a solid core, liquid mantle, and thin crust. Having a solid core resulted in having a strong gravitational force. Massive volcanic eruptions were triggered by the energy released by the particle assertion and radioactive isotopes decay. While moving through the mantle, gases dissolved in the molten magma were decreased. Volcanoes ejected water, carbon dioxide, and ammonia as steam. In seawater, carbon dioxide has dissolved. By this, the mountains are formed because of plenty of energy. There was a significant amount of nitrogen and carbon dioxide emitted into the atmosphere. The majority of carbon dioxide was dissolved in water, and carbonate sediment accumulated. Coral reefs are formed because of the carbon dioxide released from the atmosphere. The oxidizing, or the present-day atmosphere. Free O2 began to develop in the atmosphere around 2.4 billion years ago. If you haven't noticed, during the first atmosphere and the second atmosphere, there is no oxygen. No form of life is also observed. Around 2.7 billion years ago, photosynthesizing and cyanobacteria were extant, and oxygen produced during photosynthesis was utilized in the oxidation of metals such as iron. There is oxygen, however, it is only used in oxidizing metals. atmosphere began to oxidize, and life form that consumed oxygen began to arise in the world's ocean. The first life form occurred in water bodies because the form of oxygen that they take is only present in the ocean. The land oxygen is not fully developed to sustain land life forms. Photolysis. Water caused by ultraviolet light as well as photosynthesis by plants and cyanobacteria produce oxygen. The oxygen in land was formed because of ultraviolet light radiation and cyanobacteria. However, oxygen molecules higher in the atmosphere absorb UV energy and transform to ozone. Shortly after, an ozone layer emerged, protecting the Earth's surface from the UV radiation and allowing for the emergence of life on land. Plants added the atmospheric oxygen as higher forms arose on land, while animals took it for respiration, and the oxygen level stabilized around the 21% we know today.
Hola, I am Charity and B. Monera, and you've arrived at the last stage of the chemistry of the atmosphere.
Structure of the atmosphere. The atmosphere is a layer of gases that surrounds the Earth. The atmosphere might appear invisible, but it has layers starting from the ground all the way up to space. These layers are troposphere, stratosphere, mesosphere, thermosphere, and exosphere. So now, let us talk about the first layer of the atmosphere, which is the troposphere. The troposphere is a part where we live in. Also, it contains most of our weather, the clouds, the rain, and snow. It extends from the Earth's surface for about 12.5 miles in the sky. The temperature in this area ranges from 15 to negative 56.5 degrees Celsius. It traps the sun's heat close to our planet, resulting in warm and cold weather to occur. It contains about 75% of all of the air in the atmosphere and almost all of the water vapor, which forms clouds and rain. If a parcel of air moves upwards, it expands because of the lower pressure. When air expands, it cools, so air higher up is cooler than air lower down. For example, when you are living in Baguio City, since it is located in the higher region, the air in the area is cold and the temperature is decreasing compared when you are living in Manila, since it is located in a flat plain, the air in the area is hotter and the temperature is increasing. Boundary layer is the lowest part of the troposphere that is directly influenced by the presence of the Earth's surface and responds to surface forcing within a time scale of about an hour or less. The top of the troposphere is called tropopause, the boundary layer between the troposphere and the stratosphere. The tropopause is lowest at the poles, where it is about 7 to 10 kilometers above the Earth's surface. It is highest about 17 to 18 kilometers near the equator. Its height also varies with the seasons. It is highest in the summer and lowest in the winter. Stratosphere is the second layer above the troposphere. It stands from the tropopause about 11 kilometers to 50 kilometers from the planet's surface, containing 20% of the Earth's gas. The temperature in this layer increases with height. The temperature at the bottom of the stratosphere is negative 75 degrees Fahrenheit. But at the top, ice could melt because the average temperature is 32 degrees Fahrenheit. The positive temperature gradient is called a temperature inversion, and it's what distinguishes the stratosphere from the layers above and below it, and defines it as a distinct atmospheric layer. Temperatures in the stratosphere are highest over the summer pole and lowest over the winter pole. Jets fly in the stratosphere so that passengers can have a smooth ride, and also thunderstorms or rain is nowhere to be found in this layer. There is hardly any wind here because the air is thinner, but more importantly, the fact that the temperature increases with height, it means that there is no cold air accumulating at higher elevations and forming convection currents as it falls. Ozone is formed when three oxygen molecules join together, and this happens in the stratosphere because of the intensity of the sun's ultraviolet radiation. The formation of ozone absorbs this radiation, fortunately for the organisms on the ground, which would die of radiation poisoning if the ozone layer wasn't there. One of the more interesting stratosphere facts is that the ozone layer is responsible for its existence. Ozone heats up as it absorbs ultraviolet sunlight, and that's why there is a positive temperature gradient in this atmospheric layer. Without the ozone layer protecting us, we would die and we can have skin cancer. CFCs have reduced the amount of ozone in the stratosphere, particularly at polar latitudes, leading to the so-called Antarctic ozone hole. Mesosphere is the third layer of the atmosphere. The temperature again decreases with height, reaching a minimum of about negative 90 degrees Celsius at the mesopause. It extends from the stratosphere to 40 to 50 kilometers to 80 to 90 kilometers. Most meteors burn up in this sphere and rockets go up in this sphere. The mesosphere is very important for Earth's protection. The mesosphere burns up most meteors and asteroids before they're able to reach the Earth's surface. As most meteors burn up, they can be sometimes seen in the night sky. Most people call them shooting stars. Although most of the meteors that reach the mesosphere are burned up, some of their material hangs around afterward, including iron and other metallic atoms. Thermosphere is the fourth layer of the atmosphere. The thermosphere lies above the mesopause. The word thermosphere is derived from the Greek word thermo, which means heat. The temperature at the thermosphere can reach more than 2,000 degrees Celsius because the air is thin. However, it varies between night and day and between the seasons. The region of the atmosphere above is about 80 kilometers is also caused by the ionosphere. The ionosphere reflects and absorbs radio waves, allowing us to receive shortwave radio broadcasts in New Zealand and from other parts of the world. One of the most amazing sky phenomena occurs mostly in the thermosphere is called the aurora borealis or northern or southern lights. It occurs when ions, protons, and electrons from space collide with the molecules and atoms in the thermosphere, creating energy that emits light. Because outer space is believed to begin at 62 miles above the Earth's surface, thermosphere could be considered part of the space. Exosphere, the last layer of the atmosphere. Satellites and spaceships is usually found in this layer. The region above is about 800 to 3,000 kilometers and gradually fades in the vacuum of space. The bottom of the exosphere is sometimes also referred to as the exobase. Since the exosphere gradually fades into outer space, there is no clear upper boundary of this layer. Below the exosphere, it contains mainly oxygen and hydrogen atoms, but there are so few of them that they rarely collide. They follow ballistic trajectories under the influence of gravity, and some of them escape right out into space. Together, the layers of the atmosphere help to protect the Earth from greenhouse gases, working like a blanket of insulation surrounding the planet. And that is our lesson of the chemistry of the atmosphere.
Has been Group 5 explaining to you the chemistry of the atmosphere. But before we end this topic, let's have a quick recap. Eileen talked about the atmosphere as the thin envelope of gas molecules surrounding the Earth. It is held down by gravitational pull. The importance of the atmosphere, first we have, is it contains the gases that we need in order to live. Second, it maintains the Earth's temperature by absorbing the sun's energy as it arrives. Third, it protects us from the harmful ultraviolet radiation. On the other hand, Joshua talked about the composition of the atmosphere, wherein the atmosphere is made out of 78% of nitrogen and 21% oxygen and 1% of other gases. While I talk about the evolution of the atmosphere, where it takes over millions of years to develop. And we have these three stages of evolution. First, the primitive or the first atmosphere. Second, the reducing or the second atmosphere.
Third, the oxidizing or the present day atmosphere. On the other hand, Charity talked about the structure of the atmosphere, where the atmosphere is the layer of gases that surrounds the earth. The atmosphere might appear invisible, but it has layers starting from the ground all the way to the space. These layers are troposphere, stratosphere, mesosphere, and thermosphere, and exosphere. That's all for today. Thank you. This has been Group 5.